March 1979. Deep beneath the ice-covered Barents Sea, something is moving that should not exist. American underwater listening stations suddenly light up with a contact traveling at a speed that makes seasoned analysts stop breathing for a moment. The numbers don't change. Whatever this object is, it's moving faster than any submarine ever recorded. Faster than the fastest American attack boats. Faster than the torpedoes meant to destroy it. In that instant, a quiet fear spreads through naval command rooms. If this thing is real, the rules of underwater warfare may have just been broken. For decades, submarines survived by being quiet. Silence was everything. The quietest submarine lived the longest. Speed mattered, but it was never the priority. And now, suddenly, something was tearing through the deep without caring who heard it. This was not a hunter hiding in the shadows. This was a predator daring the ocean to chase it. Before we go deeper, if you love stories about secret machines, extreme designs, and engineering pushed far beyond what feels safe or reasonable, you're in the right place. This is forbidden engineering. And if you want more stories like this, take a second to like the video and subscribe to the channel. It helps more than you might think, and it lets you know when the next unbelievable machine drops. To understand how the world ended up here, we need to go back to the early Cold War. In the late 1950s, the balance of power no longer depended only on bombers or missiles on land. The oceans became the most important battlefield on Earth. Nuclear weapons didn't need runways anymore. They could hide beneath the waves, carried by submarines that were almost impossible to find. Whoever controlled the oceans controlled the future. The Soviet Union understood this clearly. Their strategy was simple and aggressive. Build more submarines than anyone else. Flood the seas with steel. Attack submarines. Missile submarines. Patrol submarines, rolling out of shipyards non-stop. By the mid-1960s, the Soviet Navy had more than twice as many submarines as the United States. On paper, it looked unstoppable. But underwater, numbers didn't tell the real story. American submarines were quieter. Much quieter. U.S. naval engineers had spent years obsessing over sound. Engines were mounted on shock absorbers. Gears were machined with extreme precision. Propellers were shaped to slide through water instead of tearing it apart. Every vibration was studied, reduced, and controlled. The result was terrifying. American submarines could follow Soviet boats for hours, sometimes days, without ever being detected. For Soviet crews, it felt like being hunted by ghosts. American submarines seemed invisible. They were there, listening, watching, waiting, but never revealing themselves. In exercises and intelligence estimates, one conclusion became impossible to ignore. If war broke out, U.S. submarines could track and destroy Soviet missile subs before they ever launched their weapons. By the early 1960s, Soviet naval planners faced a brutal reality. When it came to stealth, they were at least a decade behind. Catching up would take time, money, and industrial changes they simply didn't have. So instead of trying to win the same game, they chose to change the rules entirely. If American submarines were unbeatable because they were quiet, then the Soviet answer would be something that didn't need to hide. Something so fast and aggressive that silence no longer mattered. A submarine that could overwhelm sensors, close distance instantly, strike, and escape before anyone could react. Around 1960, Soviet engineers received an extraordinary mission. Design a submarine built not around stealth, but around raw performance. The requirements were extreme. It needed to be at least 1/3 faster than any American submarine. It needed to accelerate from a dead stop to full speed in under a minute. It needed to turn 180 degrees in around 40 seconds. In short bursts, it needed to behave less like a ship and more like an underwater fighter jet. This was not about long patrols or quiet tracking. This was about shock. A sudden burst of speed so violent that enemy tracking systems would lose lock. Torpedoes would fall behind. The submarine would strike and vanish before anyone could respond. To make this possible, everything had to change, starting with the heart of the submarine, the reactor. Traditional nuclear submarines used pressurized water reactors. They were reliable and proven, but they had limits. They couldn't produce the insane power density this new design demanded. So Soviet engineers turned to something radical, a liquid metal-cooled reactor. Instead of water, This reactor used a molten lead-bismuth alloy to carry heat. Liquid metal could transfer heat far more efficiently, allowing the reactor to generate massive power in a compact space. The payoff was extraordinary. For its size, this reactor could produce up to 3 times more power than conventional submarine reactors. With it, the submarine could go from 0 to over 40 knots underwater in just over a minute. That kind of speed had never existed beneath the ocean. Western analysts would later struggle to believe the numbers. But this power came with a terrifying price. The liquid metal coolant had to stay hot at all times. If it cooled below roughly 125 degrees Celsius, it would instantly solidify. And if it solidified inside the reactor would be destroyed permanently. There was no restart, no recovery. This meant the reactor could never truly be turned off. Even while docked, even during maintenance, the system had to stay heated. Specialized infrastructure was required just to keep the submarine alive. It was never fully asleep. It was always dangerous. Speed alone wasn't enough. To move this fast underwater, drag had to be minimized. Engineers adopted a smooth, teardrop-shaped hull, refined inch by inch. Every protrusion was questioned. Every curve was optimized. Even the bowplanes were designed to retract fully at high speed to reduce turbulence. The submarine was also made as compact as possible. Smaller size meant less water resistance. But it also meant less space inside. Traditional attack submarines carried over 100 sailors. This one could barely support a third of that. The solution was something almost unheard of at the time: automation. For the first time, computers would manage propulsion. Ballast systems would adjust automatically. Torpedoes would be loaded by machines. Navigation, sonar, and targeting would all feed into a single integrated command system. The crew wouldn't directly control every system. It would supervise them. This level of automation was decades ahead of its time. On paper, it made the submarine faster and more efficient. In reality, it introduced a level of complexity that would later haunt the program. Then came the most shocking decision of all. The pressure hull wouldn't be steel, it would be titanium. Titanium was lighter than steel, stronger for its weight, and highly resistant to corrosion. For submarines, that meant higher speeds, deeper dives, and better survivability under crushing pressure. A titanium hull could allow dives far beyond anything NATO submarines could manage. But titanium was notoriously difficult to work with. Welding it required sealed environments filled with inert gas to prevent contamination. Even advanced aerospace programs used it sparingly. Building an entire submarine from titanium was considered almost impossible. And yet, intelligence reports soon revealed something strange at Soviet shipyards in Leningrad. New submarines were emerging with holes that gleamed in the light. Steel darkens quickly. These holes did not. Western analysts suspected titanium, and the implications were terrifying. A titanium submarine could dive deeper than most NATO weapons could reach. Some estimates suggested depths close to 1,000 meters. At those depths, depth charges were useless. Torpedoes struggled. If the Soviets had succeeded, NATO's underwater advantage could disappear overnight. The West scrambled. New deep-diving weapons were rushed into development. Faster torpedoes were designed. Sonar systems were pushed to their limits. For the first time in years, the United States was reacting instead of leading. In 1972, after more than a decade of development, the first of these submarines entered the water. This was Project 705. NATO would later call it the Alfa-class. It was the most advanced submarine the Soviet Union had ever built. And then, almost immediately, disaster struck. A fault in the steam generator went unnoticed. The liquid metal coolant began to cool. As the temperature dropped below the critical point, the metal solidified inside the reactor. In seconds, the heart of the submarine was destroyed. The crown jewel of Soviet naval engineering was rendered useless, its reactor frozen into a solid block. It was a catastrophe. Technically, financially, politically, pressure mounted to cancel the entire program. Too much had already been invested. Instead, the damaged submarine was cut in half. Its forward section was sent back to Leningrad to be used as a training facility. The stern containing the ruined reactor was left behind. Engineers joked that the Soviet Union now had the world's longest submarine. It would take 5 more years to build a replacement. From the beginning, Project 705 struggled. Design work dragged on. Construction was slow and unbelievably expensive. Yet even before the first submarine finished testing, Soviet leaders ordered more to be built. An unproven design was pushed straight into production. It was a gamble. The Alpha submarines were plagued with technical issues. Automated systems failed more often than expected. Specialized ports needed to keep the reactors hot were unreliable or unfinished. Crews were forced to remain on board to keep systems running. Maintenance became nearly impossible. Plans once existed for missile-carrying versions that could threaten American carrier groups, but the problems never stopped. One by one, those ideas were abandoned. By the late 1970s, 6 Alfa-class submarines finally entered service. Not the dozens originally planned, but 6 of the most extreme submarines ever built. They were kept on high alert near the Soviet Arctic. American crews who encountered them described the experience as unsettling. The Alphas could accelerate violently. They could dive deeper than expected. They could change direction faster than anything else underwater. But speed came with a fatal flaw. At full power, the submarine became deaf. Cavitation and noise overwhelmed its sonar. The Alpha wasn't hunting. It was screaming through the ocean, blind. The reactor that could never shut down remained a nightmare. Maintenance was constant. Breakdowns were frequent. Each submarine cost roughly twice as much as a conventional nuclear sub. Supporting them required building an entire titanium industry and pushing nuclear engineering to its limits. In the end, only 7 were ever completed. By the late 1980s, most spent more time in dry dock than at sea. When the Cold War ended, the program quietly faded away. At first glance, it looks like failure. A wildly expensive experiment that didn't live up to its promise. But the truth is more complex. The Soviets weren't trying to build a better submarine. They were trying to invent something new, an underwater interceptor, a machine where speed replaced silence. For a brief moment, it worked. The Alfa-class proved that torpedoes could be outrun, that depth could be weaponized, that stealth wasn't the only answer. If you've watched this far, I'd love to hear what you think. Was this submarine a brilliant leap ahead of its time, or a warning about pushing engineering too far? Let me know in the comments. And if you know someone who would love this story, share it with them. That's how forbidden engineering reaches more curious minds, because some machines aren't built to last. They're built to prove what's possible. And once that line is crossed, engineering is never the same.
If you enjoyed this deep dive into forbidden machines and dangerous ideas, leave a comment below. I want to know what you think. Was this submarine a bold vision, or a doomed experiment from the start? And if you think this story deserves to be heard, share it with someone who loves military history or secret engineering projects. It helps forbidden engineering reach more people who appreciate stories like this. Thanks for watching.